Hello friends, we are discussing the chapter Thermodynamics, and in our last lecture we have discussed the first law of thermodynamics, and in today's lecture we are going to discuss the property of system or system variables. So what is system variable? It is measurable characteristic property of a system when the system is in equilibrium. म्हणजे एखादी सिस्टीम जर इक्विलिब्रियममध्ये आहे तर अशा प्रॉपर्टी की ज्यांची आपण मोजमाप करू शकतो. म्हणजे आपण समजा घेऊ एक्झाम्पल प्रेशर. तर एखाद्या सिस्टीम आहे त्याचं आपण प्रेशरचं मोजमाप करू शकतो. त्याचं व्हॉल्यूम किती आहे ते आपण मोजू शकतो. त्याचं टेम्परेचर आपण मोजू शकतो. त्याची डेन्सिटी आपण मोजू शकतो. त्याचा मास किती आहे मास ते आपण मोजू शकतो. सो दीज आर ऑल द कॅरेक्टरिस्टिक प्रॉपर्टी of the system which are measurable. So these and such properties are called the system variables. So these system variables like pressure, volume, temperature, etc. are measurable property. Hence they are used to describe the system. Also all these are macroscopic variables of the system. Next, we are going to discuss about the intensive and the extensive variables. Now, supposing this is a system or this is a cylinder and a piston is attached to the cylinder. So, if now this is a system, this is a cylinder, this is a piston and there is gas inside the cylinder. So this is the piston and this is the cylinder and this is gas. So supposing there is a system, this is the piston, this is the cylinder and there is gas inside the system. Now, what are the state variables which are measurable property, which are the characteristic measurable property? They are the volume of the system, then the pressure of the system, then the mass of the gas inside the system, the density of the system, the temperature of the system, the internal energy of the system. All these variables, macroscopic variables, we can find the value. आपण त्याची व्हॅल्यू फाइंड करू शकतो. व्हॉल्यूम किती आहे, प्रेशर किती आहे, मास किती आहे, आपण फाइंड करू शकतो. Now, the intensive variables are those which do not depend upon the size of the system. ही जी सिस्टीम आहे तिची काय साईज आहे याच्यावर इंटेन्सिव्ह व्हेरिएबल्स डिपेंड होत नाही. जसं जर मी ही सिस्टीम 2 पार्ट्समध्ये कट केली, हाफ केली मी ही सिस्टीम, तर प्रेशर इज गोइंग टू चेंज. तर प्रेशर चेंज होणार आहे का याचं? नाही, प्रेशर नाही चेंज होणार. त्याची डेन्सिटी चेंज होणार आहे का? तर नाही. ही सिस्टीम जरी मी हाफमध्ये कट केली तरी जेवढी डेन्सिटी त्या गॅसची आहे ती तेवढीच राहणार आहे. सो प्रेशर चेंज होणार नाही, डेन्सिटी चेंज होणार नाही, टेम्परेचर चेंज होणार नाही. So these variables, pressure, density and temperature will not change if I cut the system into 2 parts. दोन वेगवेगळ्या पार्ट्स मध्ये घेतली मी ती एकच सिस्टम. So such variables which do not depend upon the size of the system, they are the same. त्यांची व्हॅल्यू कशी राहते? सेम राहते. प्रेशर, डेन्सिटी, टेम्परेचर सेम राहतं. जरी मी सिस्टमची साईज कमी केली तरी हे प्रेशर, डेन्सिटी and टेम्परेचर हे व्हेरिएबल्स चेंज होत नाही. सो सच व्हेरिएबल्स आर कॉल्ड एज इंटेन्सिव्ह व्हेरिएबल्स. नाव एक्सटेन्सिव्ह व्हेरिएबल्स. नाव हिअर व्हेन आय कट द सिस्टम इंटू 2 पार्ट्स, मी 2 पार्ट्स केले. So naturally mass will be divided into 2 parts. So the mass will be divided into 2 parts. The internal energy will also change because the internal energy of one part will be and now other part will be different now. So the internal energy, the volume. So these variables, mass, internal energy, volume, हे change होणार है if I cut the system into two parts. So such variables which depend upon the size of the system, and if the size is decreased, size of the system is decreased, then their value also changes. Such variables are called extensive variables. The next point is thermodynamic equilibrium. A system is in thermodynamic equilibrium if first it is in mechanical equilibrium, then it is in chemical equilibrium, and it is in thermal equilibrium. So if the system fulfills all these three equilibrium conditions, then the system is in thermodynamic equilibrium. Now, what is mechanical equilibrium? First is when there are no unbalanced forces within the system and between the system and the surroundings, and the pressure throughout between the system and the surrounding is same, and the pressure does not change with time. So these are all the conditions for the mechanical equilibrium. If the system satisfies these conditions, then the system is in mechanical equilibrium. Now, what is chemical equilibrium? When is a system in chemical equilibrium? So, first, when there are no chemical reactions going on within the system. No transfer of matter from one part of the system to the other due to diffusion. म्हणजे कोणत्याही कारणाने मॅटर एका पार्टमधून सिस्टमच्या दुसऱ्या पार्टमध्ये जात नाहीये. Third is the chemical composition of the system is same throughout and it is not changing with time. So if all these conditions are satisfied, then the system is said to be in chemical equilibrium. Now, the next is thermal equilibrium. As the name suggests, thermal, that is, when the temperature of the system remains constant throughout and it does not change with time, then the system is said to be in thermal equilibrium. The next, we are going to discuss about the thermodynamic state variables. The equilibrium state of any system or any gas, or when a system is in thermodynamic equilibrium, it can be completely described by some specific values of some variables. Example, pressure, volume, temperature, mass. So all these, etc. All these are called the thermodynamic state variables. Thermodynamic state variables describe the equilibrium of the system. But when the system is not in equilibrium, then it cannot be described by the thermodynamic state variables. Mathematical relation between these state variables is called equation of state. Like for ideal gas, we have equation of state as PV is equal to nRT. So this is the equation of state. These state variables are used to explain the equation of state in case of the ideal gas. The next point is the PV diagram. Now, we are considering a system and there is ideal gas inside the system. So, the ideal gas equation is PV is equal to nRT, where P is the pressure of the gas, V is the volume of the gas, N is the number of moles, R is the universal gas constant, and T is the temperature. Now, here we are keeping the temperature constant. So, consider as the temperature is constant, because we know N, when a system is fixed, the number of moles will remain constant. R, which is the universal gas constant, that is also a constant. And here in this case, now we are keeping the temperature constant. So pressure would be changing with respect to volume, so that PV is equal to constant. So pressure would be changing with the pressure would be changing with respect to the volume, or PV is equal to constant, or pressure is inversely proportional to volume in this case. Now we are drawing the PV diagram. Now here on the x-axis we are considering the volume of the gas, and on the y-axis we are considering the pressure of the gas. Initially the system is at point A, where the volume of the system is V1 and the pressure of the system is P1. Now the system changes, and from point A to point B, it changes from A to B, and now the volume of the system is V2, that is, the volume of the system has increased, and the pressure of the system has decreased, which is P2. The graphical representation of equation of a state, of a system, of a gas is called the PV diagram. It is also called the PV curve, or the pressure volume curve, or it is also called indicator diagram of the system. Now this PV diagram represents change in state of gas from point A, that is V1 P1, to point B, that is V2 P2, at constant temperature. Hence this PV diagram is, since it is at constant temperature, it is also called as isotherm. Such PV diagram which is at constant temperature is also called as isotherm. So in the next lecture we would be discussing more such PV diagrams.